For part A of this question, we are required to find dy over dx, and then for part B, we are required to find the equation of the normal to the curve at the point 1, 1. So for part A, we can just go ahead and start differentiating this equation implicitly. But before we differentiate, we need to expand it. So expand the left hand side, and that will be x to the power 4 plus 2x squared y squared plus y to the power 4 will be equal to 4xy squared. And then we can differentiate this equation implicitly. So derivative of x to the power 4 plus, now we can differentiate this using product rule. So that will be 2x squared multiplied by the derivative of y squared plus y squared multiplied by the derivative of multiplied by derivative of 2x squared plus the derivative of y to the power 4 will be equal to, again for this we have to use product rule. So for x multiplied by the derivative of y squared plus y squared multiplied by the derivative of 4x. Okay, now if we find these derivatives here, we'll have 4x cubed plus, so this will be 2y divided by dx. If we multiply by that, that will be 4x squared y dy over dx plus this will just be 4x multiplied by y, so 4xy squared, and this will be 4y cubed dy over dx, 4y cubed dy over dx, and that will be equal to, this will be 2y dy over dx multiplied by that, that will be 8xy dy over dx plus, and this will be 4, so just 4y squared. Now what I'm going to do next is two steps in one. I'll bring all this to the left and factorize dy over dx and take this to the right. So basically what I'll end up with here will be 4x squared y plus 4y cubed minus 8xy dy over dx will be equal to 4y squared minus 4x cubed minus 4xy squared. Okay, so and then remember what I'm looking for basically here is dy over dx. So dy over dx, dy over dx, or the resulting expression for dy over dx will be equal to 4y squared minus 4x cubed minus 4xy squared over 4x squared y plus 4y cubed minus 8xy. Now we can divide both the numerator and denominator by 4. If you divide this by 4 and this by 4, so we shall end up with a simpler expression. So basically that will be y cubed, actually y squared minus x cubed minus xy squared over x squared y plus y cubed minus 2xy. Okay, so that's part A. and that will be the expression for dy over dx. Now for part B, we want to find the equation of the normal to the curve at the point 1, 1. So for part B, um, to find the equation of the normal, we have to know the gradient of the tangent at that point, or the gradient of the curve at that point. So we can start by finding the gradient of the tangent, which is same as the gradient of the curve at that point. So gradient of the tangent at 1, 1 will be equal to, so we plug 1 in place of x and y, so that will be 1 minus 1 minus 1 over 1 plus 1 minus 2, if you plug 1 in place of x and y. And this will be equal to negative 1 over 0, which is undefined. So what does that mean? That means that they it means that the equation of the tangent at this point is vertical. Yeah, and because the equation of the tangent at this point is vertical, that means that its gradient is undefined, as you can see here. Yeah, so because this point is 1, 1, it means that the equation of the tangent is actually x is equals to 1. Yeah, so we can therefore say that this implies that um, the equation of the tangent at 1, 1 um, equation of the tangent at 1, 1 is vertical. Yeah, like I said, which is x equals to 1. So that's the equation of the tangent, and that's why its gradient is undefined. So the equation of the normal at 1, 1, so the equation of the normal is y is equals to 1. Yeah, because the normal and the tangent are perpendicular to each other at the point where they are formed. And because this point happens to be 1, 1, the equation of the tangent is x equals to 1, and the equation of the normal is y is equals to 1.